Alright, now that we understand limits at infinity, let's move on to an important concept called horizontal asymptotes. A horizontal asymptote describes the value that a function approaches as x becomes very large or very small. If the limit of f of x as x approaches infinity equals L, or the limit of f of x as x approaches negative infinity equals L, then the line y equals L is a horizontal asymptote. Now, let's make that idea more visual by looking at these graphs. On the left graph, notice what happens when x moves far to the right and far to the left. The curve gets closer and closer to the horizontal line. It doesn't necessarily stay on the line, but it keeps approaching it. That horizontal line represents a value the function is approaching. This is what we call a horizontal asymptote. Now, look at the graph on the right. The curve is getting closer and closer to a vertical line. As it gets close, the function increases or decreases very quickly, but it never actually crosses that vertical line. This is called a vertical asymptote. Here is a very important point. A function can cross a horizontal asymptote, but a function cannot cross a vertical asymptote. Now, let's apply it to an example. We are given a function f of x equals 5 minus 2 over x squared, and we want to find the limit of f of x as x approaches infinity, the limit of f of x as x approaches negative infinity, and the horizontal asymptote. The limit of f of x as x approaches infinity, we replace f of x with 5 minus 2 over x squared. So we want to find the limit of 5 minus 2 over x squared as x approaches infinity. As x approaches infinity, x squared becomes very large. So 2 over x squared becomes very small, and it approaches 0. So the function becomes 5 minus 0, which is 5. Next, we are going to find the limit of f of x as x approaches negative infinity. Again, we are going to replace f of x with 5 minus 2 over x squared. As x approaches negative infinity, x squared is very large. So again, 2 over x squared approaches 0. So I have 5 minus 0, which is 5. So the limit of f of x as x approaches infinity is 5. And the limit of f of x as x approaches negative infinity is also 5. Since both limits are equal to 5, the horizontal asymptote is y equals 5. Now, one very important detail. The horizontal asymptote must be written as an equation of a horizontal line. So it must be in the form y equals a number. That means the correct answer is y equals 5, not just 5. If you only write 5, that is not correct because 5 is just a number, not a line. The asymptote is a line, so we must write y equals 5.